So as you guys can see, I can't calculate torque, so that is why I'm in debt.
Double down.
So pause and read the problem until you get to horizontal surface, and after you get to the part where it says another horizontal surface where the cursor is at right now, I'll scroll down for you just so that the watermark doesn't block everything as usual. And feel free to look at the diagram after you finish reading the whole thing. So we have to find the tension of string A in terms of gravitational acceleration, mass 1, L, D, mass 2, and X. So as you can see, the whole thing is in static equilibrium. So basically, nothing is moving. It's basically like some kind of modern art sculpture or something. So yeah. So basically, the net torque of this whole thing around what would be the best axis, which I call P here, would equal 0. And the best axis is basically arbitrary when an object is in static equilibrium. But I don't know about you guys, but I'm gonna assume that the torque of B would be the best axis in this case.
Raymond, you said an opinion. Now you're the enemy of the people.
So as you can see, we have to calculate torque B. So as you can see, the tension in A is pulling the mass up, and it's D away from where string B meets the rod, where it meets the bar or something. And the torque is basically force times the radius times side of phi, but then phi is 90 degrees for all the torque that will be explained here. So side of 90 degrees is 1, so we just leave the angle out of it. So it will be TA with T sub A, times D, and that will be the counterclockwise force of string A. And then there's a clockwise force called gravitational force, and it's acting in both ways from mass 1 and from L distance, and from mass 2 from X distance. And by the way, I lied. I meant mass times L divided by 2, since L divided by 2 is basically just halfway, and the force is acting halfway. So yeah. So since it's going clockwise, the torque has to be negative here. So mass sub 1 times G times L over 2. This is probably blocked by the watermark. Ilmora. And then there's another clockwise force, and that's mass 2. And mass 2 is X distance from B. So mass 2 times distance X times G. And there you go. That's your torque force for B in these arbitrary terms. And yeah.
Jesus, take the wheel. Take it from mine.
So now we have to isolate the tension on string A to get the answer, and then probably go to sleep, I guess, and finish this whole thing. So we have the equation for torque of B, but since the whole apparatus is in equilibrium, and we chose that the best axis would be the part where string B meets the bar, the torque of B is basically just 0, so there's nothing there. So what I did was move the tension on A times D to the opposite side, and then multiply everything by -1. And then after that, you can factor out the G's, and the G is over here now. And then after that, to isolate tension of A to get your final answer, divide both sides by D, and there you go. You have your answer. The tension in A equals the gravitational acceleration over distance D times the quantity of mass 1 times length L over 2 minus mass 2 over distance X. And there you go. That is your answer for problem 3. Well, that's my answer. You guys probably got a different answer, but anyways, if you liked the video, please drop a dislike. No likes, please. Dislikes only, and see you in the next video later. Jesus.